Hello. Today we will be covering how to perform USB 2.0 high-speed device testing. This video will cover the necessary hardware and software, physical connections, and test software configuration necessary for high-speed quality testing. Here is a list of the instruments, fixtures, and software used for this testing. We will be using the Tektronix MSO5204B and legacy USB2 test fixture. We will also be using the TDP 1500 active differential probe and USB high-speed electrical test tool installed on our host PC. To start, we'll need to make sure we have the necessary test software and scope application software used in this testing. TDSUSB2 may be found by going to tech.com and doing a search for TDSUSB2 using the Downloads Finder in the bottom half of the screen. The link that we want is for just the TDSUSB2 software. We don't need the complete scope deployment package. Assuming that you have option USB already enabled on your oscilloscope, you simply need to download and install this software on your oscilloscope. Next, we'll need the high-speed electrical test tool and electrical analysis tool from USB.org. Simply click on Developers, Tools, then USB 2.0 Tools. And what we need are the USB electrical analysis tool and the USB high-speed electrical test version 1.2.2.1. So you'll want to download the USB ET20 software as well as either the 32-bit or 64-bit of the electrical high-speed electrical test tool depending on what operating system you're using. Once you have these downloaded and installed on your host PC, we'll be able to look into making the connections to our test fixture and oscilloscope. A point to mention about the high-speed electrical test tool is that when running, it will take control of all USB ports associated with that particular PCI bus on your host PC. This means that these ports will be unusable while testing. Since you still need access to your mouse and keyboard, the options are to use a PS2 mouse and keyboard, use USB ports associated with a different PCI bus on your PC, if possible, or any available USB 3 ports on your PC. Now that we have all the necessary software downloaded and installed, we need to connect all our hardware. In this test, we will be powering our board via USB using USB B port J92. Our host PC is connected to USB B port J37, and our DUT will be connected directly adjacent to our host PC port to USB A port J34. Our TDP 1500 Pro will be connected to the D+, D- J310 test points. Lastly, we make sure that the S6 switch is set to the init or initialize position at this time. Here is a shot of our actual test fixture and connections. The USB cable on the right is for power. The USB cable on top is connected to our host PC. You can see our probe connected to the J310 test points. You'll also notice that our device is not connected to the fixture yet. You'll see why in just a few minutes. Now we need to run the high-speed electrical test tool. This tool sends commands to our device under test, putting it into the proper test mode. In my case, my host PC has multiple PCI buses for the various USB ports. I've determined the correct bus needed through trial and error. Device is selected as the default type of test. After clicking Test, you'll see a new window with a list of USB devices. Now we know our DUT isn't in the list as we've not plugged it in yet. The simplest way to find the ID of your DUT is to now plug it in and enumerate the bus. Here we see that after I connect my device and click Enumerate, a new device appears. Now I know that my device ID is 3234. The last step using this software is to select the test packet device command and click Execute. Now it's time to switch over to our oscilloscope. At this point we need to flip the switch on the fixture from init to test. You can see the change to the signal when we switch to test, isolating the device under test, so all we see is the test packet transmission. Now we can start the TDSUSB2 software and run our analysis. When installed, the TDSUSB2 software will appear in the Analyze drop-down tab on your scope. Once running, we're going to select all of the high-speed signal quality tests, then click Configure. The general convention is that upstream is for device testing and downstream is for host testing. For test point, we select far end. Far end is used for devices with captive cables, vendor-specific cables, or USB A-type connections. Our thumbstick, of course, uses an A-type connection, and it also has a captive cable model. Once we've made sure that our measurement is configured correctly, we need to check that our source is correctly set to differential. Once this is done, we can click the Running Man. As the test runs, you'll be prompted to click OK when the waveform is acquired. Once the test completes, you'll see the eye diagram and captured packet used for testing. Clicking on any of the pass-fail icons will show you the exact measurements taken along with the standard requirements. Now, USB-IF requires that signal quality test calculations be performed using their analysis software. This is why we downloaded and installed the USB electrical analysis tool at the beginning. To save the captured waveform data, go to File, Save As, Waveform, and save Channel 1 to a USB thumbstick to transfer to your host PC. After starting the analysis tool, simply browse to the correct file location. In this case, as I've mentioned, I already transferred my saved waveform file to a temp folder on my host PC. Make sure that the proper test type is selected, in our case, high-speed near end, and click Test. You should see the same results as we saw on our oscilloscope. Pass-fail information, the actual measured values, as well as the captured data and the eye diagram associated with the captured data. This concludes our video on USB 2.0 high-speed device signal quality testing. My next video will be covering the packet parameter portion of the USB compliance testing for USB 2.0 devices. I hope this video was informative, and I hope that you also take the time to watch the following videos completing the USB 2.0 compliance test solution from Tektronix.